Hello everyone, hope you all are doing good. I am Anjana from Learnohub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Physics Chapter 12. This is the last chapter, Radioactivity. We will be discussing the topic Atomic Structure and Radioactivity. Are you all ready for the session? Let's begin. Structure of atom. We know everything is made up of atom. Even our human body is made up of atom. This pen, a book, board, everything is made up of atom. An atom consists of three important particles. What are they? Electrons, protons and neutrons. Protons, electrons and neutrons. Protons are positively charged. All this we have studied in class 9th. Electrons are negatively charged and neutrons no charge. Okay, so these are the three important particles in atom. They are called subatomic particles. Okay, this is how an atom looks like. So inside an atom, protons, electrons and neutrons have different positions. So inside the atom, there is a nucleus. Inside the nucleus, we have the protons and the neutrons. So this orange color shows the protons. Okay, these are protons. And neutrons, green color, we have neutrons. They are inside the nucleus of an atom, that is at the center of an atom. And then we have electrons. These electrons will be revolving around the nucleus in circular orbits. These circular orbits are also called shells. Okay. These are called shells. Okay. Protons and neutrons are inside the nucleus of an atom. Electrons revolve around the nucleus of an atom in circular orbits. Now, while moving in these orbits, electrons, they do not radiate energy and therefore these orbits are called stationary orbits. For example, if you are considering this electron, you can see this electron is revolving in this orbit. Okay, this orbit is a stationary orbit. Why is it called a stationary orbit? Its energy does not change. The electron will be having the same energy when it is revolving around the nucleus in this orbit. If it is moving from one orbit to other or one energy level to another energy level, only then it will be radiating energy. So within an energy level or within a shell, there is no radiation of energy. Therefore, this is a stationary orbit. So we have understood that electrons are revolving around the nucleus in circular orbits called shell. So for an atom, there are different atoms for different elements. We know hydrogen, helium, lithium, beryllium. There are different elements. So the atoms of different elements will also be different. So these atoms, in these atoms, there will be different number of shells. The number of shells can be calculated depending upon the electrons. Or if you know the number of shells, you can calculate how many number of electrons they can accommodate. So here you can see this blue color is the nucleus. Around the nucleus, you can see many circular orbits. So this is the first orbit, this is the second orbit, this is third orbit and this is the fourth orbit. Okay. So the number of shells in an atom depends on the total number of electrons in it. So here you can see the first shell. Okay. This shell is called K shell. Okay. If n is equal to 1, number of shells. Okay. If n is equal to 1, then it is called K shell. If n is equal to 2, then it is L shell. And if n is equal to 3, M shell, n is equal to 4, N shell. Okay. Now, in each of these cells, there are electrons. Electrons will be filled inside these shells. Okay. Then the electrons will be revolving around the nucleus in these shells. Clear? So, here we can calculate the total number of electrons. To calculate the total number of electrons in each shells, there is a formula that is 2n square. This is called 2n square rule. Okay. For example, if you are considering n is equal to 1, that is energy level 1, first shell. Okay. When you consider first shell, what is n value? N value will be equal to 1. When n is equal to 1, 2n square will be equal to 2 into 1 square, which is 2. Okay, so the first energy level or first energy shell can accommodate only 2 electrons. Clear? Now, the second one, how to calculate if n is equal to 2? Then 2n square will be equal to 2 into 2 square, which is equal to 2 square 4, 4 2s are 8. Okay, so the second shell can accommodate 8 electrons. Now if n value is equal to 3, then 2 into 3 square, which is equal to 2 into 9 equal to 18. So the third energy level can accommodate 18 electrons. Okay, so the electrons in a shell will be having the same energy which we have discussed before. Only if the electrons jump from one orbit to the other orbit, there is a change in energy. If it is orbiting in the same shell, then the energy will be the same. For example, if you are considering 2 electrons which are in the same shell, okay, so this is a stationary orbit, then the electrons will be having the same energy. Clear? Now if n value is equal to 4, then 2n square will be equal to 2 into 4 square equal to 2 into 16 equal to 32. Now if n value is equal to 5, that is after n shell, okay, then you will be having 2n square is equal to 2 into 5 square, which is equal to 2 into 25, that is 50. Okay, so 50 electrons. In the fifth orbit, we can accommodate 50 electrons. So now if the number of shell n value, if you know, you can calculate the number of electrons. Clear? So this is how we calculate. The rule is 2n square. This is the maximum number of electrons. For example, if you are having, let's say, 6 electrons. In an atom, there are 6 electrons. Then you will be having K shell. K shell will contain 2 electrons. Okay. Then the remaining 4 electrons will go to the L shell or the second energy level. Okay. For example, if the number is 10, 2 electrons will go to the K shell. Remaining 8 electrons will be in the L shell. If the number is 11, then if you are having K shell and L shell, is that enough? No, right? K shell can accommodate only 2 electrons. L shell will take 8 electrons. Still, 2 plus 8 is 10. 1 electron is remaining. This 1 electron will go to the M shell. Okay, so this is how the electrons are distributed in the different orbits of an atom. Next, atomic radius. To calculate the size of an atom, atomic radius is used. The size of an atom is determined by the radius of the shell of its outermost electron, and it is of the order of 10 raised to minus 10 meter. As we said, if the number of electrons is 10, we know that there will be K shell and L shell. K shell will contain 2 electrons and L shell will contain 8 electrons. So here you will be having nucleus at the center. So first shell, second shell. There are only 2 shells, K shell and L shell. Now when you take an element with number of electrons equal to 11, then you will be having 2 electrons in the K shell, 8 electrons in the L shell and 1 electron in the M shell. Okay, so we need 3 shells. Nucleus, K shell, L shell, M shell. Okay, so here you can see there are only 2 shells, here there are 3 shells. Okay, so to calculate the atomic radius, we'll start from the center of the atom and till the end of the shell you have to go. Okay, so here this is the outermost shell and this is an inner shell. Inner shell contains 2 electrons. There are K shell and L shell. Total number 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are there. In the outermost shell, you can accommodate 8 electrons here. There are only 6 electrons. Okay, so number of electrons here is 8 electrons. So this is how the electrons are distributed. Only 2 shells are there. So to calculate the atomic radius, we have to start from the center and the end of this orbit you will go. Okay, then calculate the radius. Radius will be in 10 raised to minus 10 meter will be approximately in this range it will be there. So as the number of shells increases, what happens? The radius also increases, then the size also will be increasing. Structure of nucleus. We have studied the structure of atom. Now let us take the structure of nucleus. Nucleus will be at the center of an atom. Inside the nucleus you will be having protons and neutrons. Protons are positively charged, neutrons zero charge. There is no charge in neutrons. Okay, they are neutral particles. Now these electrons will be revolving in circular orbits around the nucleus. So electrons are not contained within the nucleus. Okay, these protons and neutrons are together called nucleons. Okay, so nucleons contains both protons and neutrons. Now we know that protons are positively charged and the neutrons there is no charge. Therefore, the nucleus is actually positively charged. Okay, they are positively charged. Now the size is of the order of 10 raised to minus 15 meter to 10 raised to minus 14 meter, which means it is about 10 raised to minus 5 or 10 raised to minus 4 meter times that of atom. So atom size or atom radius we got 10 raised to minus 10 meter. It was of the range of 10 raised to minus 10 meter. Okay, and this nucleus consists of the protons and neutrons. Now we have to study the charge and mass of these subatomic particles. Okay, as we said, neutrons there is no charge, protons positive, electrons negative. Okay, now we'll take the mass. Okay, charge of proton and mass of proton. Charge of proton is 1.6 into 10 raised to minus 19 coulomb. When you take the charge of electron, the value will be the same. Only difference is there will be a negative side. Minus 1.6 into 10 raised to minus 19 coulomb is the charge of an electron. Okay. Next is mass of proton. You can remember this way. Mass of proton and mass of neutron are the same. Charge of proton and charge of electron are the same. Okay. Same in magnitude, but there is a negative sign for electron. Okay. Now the mass of proton is 1.67 into 10 raised to minus 27 kilogram and that of neutron is 1.67 into 10 raised to minus 27 kilogram. Okay. What about the charge of neutron? Charge of neutron is 0. Then you need the mass of electron. Mass of electron is equal to 9.1 into 10 raised to minus 31 kilogram. So just remember these values. You can compare and study. The charge of proton and electron are the same with different signs. Mass of proton and mass of neutron are the same. Charge of neutron is 0. And then you have only one thing to study, which is the mass of electron, 9.1 into 10 raised to minus 31 kilograms. Okay. Now you have to remember one thing. When you take an atom, the number of proton will define its position in the periodic table. Next is atomic number and mass number. What is atomic number and what is mass number? So normally we represent an atom in this way. Okay. X, Z, A. Okay. Here X is a symbol of that element. For example, if you are having hydrogen, then it is H. Then if you have helium, it is He. Sodium, Na. Okay. So this is how you have different elements. Now to the left bottom, you will be representing the atomic number. Atomic number is represented by the symbol Z, capital Z. And then to the top left, you will be having the mass number represented by A. Remember, mass number A and atomic number is Z, not atomic number A. Okay. Clear? So what values do they have? To get the atomic number, you have to find the total number of protons in an atom. Okay. So Z value is called the atomic number, and atomic number is the total number of protons in the atom. Total number of protons and the total number of electrons will be same in the case of a neutral atom. If you are considering a neutral atom, then they will be same. Now to get the mass number, you will have to find the total number of nucleons. What are nucleons? Protons and neutrons together we call nucleons. So protons, number of protons plus number of neutrons will give you the mass number A. Okay. So you have to study the definition. Atomic number. The atomic number of an atom is the number of proton in its nucleus. For example, if you are taking sodium, okay, sodium, atomic number is 11. What does it mean? There are 11 number of protons. Okay, atomic number is 11, proton number is 11, and electron number will also be 11 because this is a neutral atom. Clear? Okay. So based on this number, we can find its position in the periodic table. Now, if you have another atom, for example, if you are taking carbon, the atomic number is 6 and mass number is 12. What does it mean? 6 is the number of protons, 6 is the number of electrons, and also 6 is the atomic number. What is 12? 12 is the total number of nucleons. It is a mass number. Number of protons plus number of neutrons will give you the value 12. So mass number we can define, the mass number is equal to the total number of nucleons inside the nucleus. Clear? You know how to find atomic number and the mass number, and this is how we represent an element with its atomic number and mass number. Symbol, charge and mass of subatomic particles. So the different subatomic particles are given: electrons, protons and neutrons. Their symbol, charge and mass. So electrons are represented by E, protons by P and neutrons by N. Charge, for electron and proton the charge are same. Only difference is this is negative. Electrons are negative and protons are positive. 1.6 into 10 raised to minus 19 coulomb. Unit of charge is coulomb. We know. So 1.6 into 10 raised to minus 19 coulomb for proton. This is positively charged. What about the neutrons? It is charge is 0. Okay. Next, mass. 9.1 into 10 raised to minus 31 kilogram for electron. Proton and neutron same value, 1.67 into 10 raised to minus 27 kilogram. So comparing to electron, when you compare the mass of proton, neutron and electron, you can see that the mass of electron is less. Okay, so we say that inside an atom, the mass of the atom is concentrated at the center of the atom, which is at the nucleus. Why? Because the proton and neutron are only considered there. Okay, now to get the total charge of the nucleus of an atom, we will have to multiply the atomic number with the charge, electron charge. You have just need to take the magnitude 1.6 into 10 raised to minus 19 coulomb. The value that you will get with magnitude, you will have a positive sign because the charge of a nucleus is positively charged. It contains only protons and neutrons. So here this E means only the value, that is 1.6 into 10 raised to minus 19 coulomb. Okay. Now let's move on to radioactivity. Henri Becquerel is known as the father of radioactivity. Henri Becquerel discovered the phenomenon of radioactivity in the year 1896. Okay, he is an experimental physicist. Also, he is a French physicist. Okay, one day what happened is, he took a black paper and in a dark room, he took some uranium salt and wrapped it inside the black paper. And it was kept on a photographic plate. So after some days, when he took this and checked, he could see that the photographic plate had been affected, which means it has reacted. Some reaction has happened here. He understood that the uranium salt has produced some radiations which has affected the photographic plate. That is, this radiation could penetrate through the black paper. In place of black paper, if it was wood, also this penetration would have happened. So with this uranium salt and other salts of uranium, the same results was found. Okay, so uranium and its salts emit some kind of radiations which can pass through the photographic plate and affect it. These rays came to be known as Becquerel rays. Okay, these rays are known as Becquerel rays. So the father of radioactivity is Henri Becquerel. So on further investigation, he found that there are three important particles, three types of radiations. One is positively charged, second negatively charged, and the third is uncharged. These positively charged radiation is called alpha rays or alpha particles. Okay, this is the Greek letter alpha. Next, beta rays are negatively charged particles, and uncharged particles or uncharged rays came to be known as gamma rays. Okay, so these different rays can penetrate through different substances. When you take the case of alpha rays can be stopped just by using a paper. Okay, it may pass through a black paper, but it is not necessary that through all thick paper when taken, it may not be passed. Okay, next, beta rays can pass through the paper, but it will be stopped using an aluminium. Gamma rays, when you take, it can pass easily through the paper, it can pass through the aluminium, you need lead to stop it. So these investigations and experiments were done by the scientist. Okay, now we can say that when you take some atoms, that is, for example, atomic number greater than 82, that is from in the periodic table from lead onwards, you can see when you take the isotopes of these, the number of neutrons will be greater than the number of protons. So normally when you take, for example, some atom like sodium, we know that 11 is the atomic number and 23 is the mass number, which means the atomic number is equal to number of protons. Yes, so the number of protons is equal to 11. What about the mass number? Mass number A will be equal to. Mass number will be equal to number of protons plus number of neutrons, which means number of protons equal to the atomic number plus the number of neutrons is the mass number. And then the atomic number plus neutron number. You can get the neutron number by subtracting the atomic number from the mass number. Okay, so here 23 minus 11 equal to 12, which is approximately equal 11 and 12. Okay, so when you go to atoms with atomic number greater than 82, there is a difference in the number of neutrons and number of protons. So for them to come to the stable state, these radiations will be emitted. So examples for such substances are uranium, radium, polonium, thorium, actinium, etc. Okay, so we can define radioactive substance, the substance which disintegrate or decay by the spontaneous emission of radiations are called the radioactive substances, and these are the examples. Okay, to come to the stable state, they will be giving out the radiation. They can be alpha radiations, beta radiations or gamma radiations. Okay, so these emissions we will be discussing in detail. In radioactivity, we have said that there is emission of radiation. So if there is any physical change, what are the physical changes? For example, physical change. Temperature change is a physical change. Then change in pressure. Pressure change. Okay, so these are physical changes. So if there is any physical change or chemical change, what are the chemical changes? For example, if you are freezing, then if you are heating. So these are all examples of chemical changes. So when there is a physical change or chemical change, the rate of decay or the radioactive emission does not get affected. Okay, which means all these are affected by the orbital electrons. So when you bring a physical change or a chemical change, the orbital electrons will be affected and not the nucleus. So the radioactivity or these radiation emission is affected due to the change in some changes that can affect the nucleus of an atom. Okay, so the radioactivity can be called a nuclear phenomenon. Okay, it is the process of spontaneous emission of alpha, beta and gamma radiation from the nucleus of atoms during their decay. Okay, this cannot be affected by the some simple physical or chemical changes. Before we study the nature of alpha, beta and gamma particles, let's understand Rutherford's experiment. Rutherford experimentally studied the nature of radiations emitted by the radioactive substances. So here we have a source of alpha particles and a thin gold foil was used. So here we have studied different atom models. Rutherford's model is one of it. Okay, so this source of alpha particles, from the source of alpha particles, the alpha particles were passed to the gold foil and a fluorescent screen was kept here. Okay. Now what happens to the photographic plate? So here you can see the alpha particles. Some of the alpha particles rebounds, some gets undeviated, some get scattered. So this is Rutherford's alpha particle scattering experiment. Here we are understanding the nature of alpha particles. What happens to alpha particles when there is a magnetic field or when there is an electric field, we will be discussing now. Next is the deflection of radioactive radiations in magnetic field. So when these radioactive radiations are made to pass in a magnetic field, here the magnetic field is perpendicular to the plane of paper. Okay, so plane of this board, the magnetic field is provided perpendicular, it is inward. Okay, then what happens to the radioactive radiations? These radioactive radiations splits into three constituents. One moves to the left, second one moves to the right, and the third is undeviated. Okay. On subjecting the radiations from a radioactive substance to a magnetic field in a direction perpendicular to their path, they separate into three distinct constituents. Deviate to the left. So here you can see the particles which deviate to the left are called alpha particles or alpha radiation. So this is how you will be representing alpha part. This is a Greek symbol alpha, Greek letter alpha. Okay, so alpha particle deviates to the left. Then you have beta particles which deviate to the right in the magnetic field. You can see that the deviations to the beta particles are greater compared to that of alpha particles. Now what about gamma particles? They are undeviated. They are actually electromagnetic radiation, so they do not deviate in the presence of a magnetic field. Like light, they remain undeviated in the magnetic field. Okay, so these are gamma radiations. Deflection of radioactive radiations in electric field. Now on subjecting the radiation from a radioactive substance to an electric field in a direction again perpendicular to their pair, they separate into three distinct constituents. The constituents are the same. So one will deviate to the negative plate. So you are providing electric field. To provide electric field, there is a positive plate and there is a negative plate. One will deviate to the negative plate, the other will deviate to the positive plate, and the third one will remain undeviated. So undeviated, of course, it is the gamma rays. Okay. Next, alpha and beta. So turn towards the negative plate. You can see the alpha radiations are turning towards the negative plate. Okay. Then towards the positive plate, beta particle is towards the positive plate. Again, you can see the deviation produced by the beta is large compared to that of alpha. Okay. In the case of whether it is magnetic field or electric field, deviation or bending that is happening to beta particle is greater compared to that of alpha particles, and undeviated gamma particles. Why? Because they are electromagnetic in nature like light. Therefore, they do not get deviated in electric field as well. Now, let us discuss the properties of alpha, beta and gamma particle. First, the properties of alpha particle. First property, an alpha particle consists of 2 protons and 2 neutrons. So here you can see a helium atom. A helium atom contains 2 protons, 2 neutrons and 2 electrons. Okay. So this is how you represent a helium atom. Helium atom, the atomic number is 2 and mass number is 4. Okay. Now, when you take a doubly ionized helium atom, that is helium-2 positive, it doesn't contain any electrons. So a doubly ionized helium atom is an alpha particle. Okay, this is how you represent an alpha particle. Okay, now to this doubly ionized helium atom, when you add an electron, what happens? It becomes singly ionized helium atom. Okay, He positive. Again, if an electron is added, it becomes a normal helium atom. Okay, so here you will understand one thing. The mass number of helium is 4. Okay, for alpha particles, there are 4 particles, 2 protons and 2 neutrons. Clear? So, an alpha particle consists of 2 protons and 2 neutrons. This is the first point. Second point, the mass of an alpha particle is roughly 4 times the mass of a proton. What is the mass of a proton? Mass of a proton is represented as mp, and that is equal to 1.67 into 10 raised to minus 27 kilograms. Okay, this is the mass of a proton. 4 times the mass of proton means 4 into mass of proton, that is equal to 4 into 1.67 into 10 raised to minus 27 kilogram, which is equal to 6.68 into 10 raised to minus 27 kilogram. What about the charge of alpha particles? Charge of alpha particle, here there are 2 protons, okay, and 2 neutrons. Neutrons are chargeless. Protons, there are 2 protons, therefore 2 into charge of 1 proton, which is 2 into 1.6 into 10 raised to minus 19 coulomb, that is equal to 3.2 into 10 raised to minus 19 coulomb. So, the charge of an alpha particle is 3.2 into 10 raised to minus 19 coulomb. So, with this charge and mass, we can calculate Q by M, which is a specific charge. Okay. Next, the speed of alpha particle is of the order of 10 raised to 7 meter per second. Speed and energy of alpha particle is not same for all the radioactive substances. Okay, for different radioactive substances, there will be different alpha particles. So, these alpha particles speed and the energy will be different. Even from the same radioactive source, sometimes there will be a small range difference in energy and speed of the particle. Next, an alpha particle strongly ionizes the gas through which it passes. So, ionizing power of alpha particle, when it ionizes a gas, it is very high, comparing it to the beta particle and gamma particle. So, the ionizing power of alpha particle is 100 times that of beta particles and 10,000 times that of gamma particles. Okay. So, ionizing power is highest or maximum for alpha particles. Got it? Next, the fifth property, an alpha particle rapidly dissipates its energy as it moves through a medium and therefore its penetrating power is quite low. So, comparing alpha, beta and gamma particle, penetrating power is the lowest for alpha particle. It can go through air only 3 cm to 8 cm, or when you keep a thick paper or a thin cardboard, it cannot pass. It can be blocked. Alpha particle cannot pass through the skin. So here you can see paper, aluminium, lead and concrete. Okay. So an alpha particle can be stopped just by using a paper. You can see the beta rays, gamma rays or neutron particles will pass through these paper. But just by using a paper, you can stop the alpha particle. Just by taking a thick paper, you can stop the alpha particles. Sixth point, alpha particles are positively charged, so are deflected by the electric and magnetic field. We have studied the alpha particles, beta particles and the gamma particles, how their deflection is in electric and magnetic field. You can see that the alpha particle will get deflected in the electric and magnetic field because they are positively charged. In case of electric field, when there is an electric field, the alpha particle moves towards the negative plate and towards the left side when there is a magnetic field. Seventh point, alpha particle affect photographic plate. When a photographic plate is kept, you can get the images because alpha particle will react with the photographic plate. Next point, alpha particle cause fluorescence on striking a fluorescent material. You know what a fluorescent material is. For example, radium, when kept in dark, you can see it shining. So this is an example of fluorescent material. So similarly, alpha particle can also shine. Okay, so this property is called the fluorescence of the material. So this is again a property of alpha particles. Next, ninth property, alpha particles have large kinetic energy and momentum with them. Because of this, they can be made to bombard with elements, atoms of an element to convert it into another element. This is called transmutation. Next, alpha particles destroy the living cells and also cause biological damage. Okay, they can destroy the human cells or any other living organism. Cells can be damaged. Also, it can cause biological damage. So, using alpha particle, they will cause biological damage. So, we will make a comparison between alpha, beta and gamma. So, you will understand it better. Next, alpha particles get scattered while passing through the tin mica or gold foil. So, we have studied Rutherford's alpha particle scattering experiment in which we understood that alpha particles get scattered. Clear? So, these are the important properties of alpha particle. We have discussed 11 properties. Now, the properties of beta particles. Beta particles are the fast moving electrons emitted from the nucleus of an atom. So, beta particles like alpha particles, they are represented as beta minus 1, 0. So, alpha particle, as we said, it is helium 2, 4. There is both atomic number and mass number. Mass number is 4. So, when you take a beta particle, there is no change. There is no mass number because neutrons and protons are not involved. And the atomic number, in place of atomic number, will be having minus 1. Can also represent it as electron symbol minus 1, 0. Both are okay. Next, the rest mass of beta particle is same as that of electron, which is 9.1 into 10 raised to minus 31 kilogram, and its charge is minus 1.6 into 10 raised to minus 19 coulomb, same as that of electron. Okay, so with the charge and mass, we can find the specific charge. Specific charge is equal to charge by mass. Here the charge is minus 1.6 into 10 raised to minus 19 divided by mass 9.1 into 10 raised to minus 31 coulomb, and the unit is kilogram. So this will be equal to, you will be getting a value 1.76, negative sign. When you take magnitude, it is 1.76 into 10 raised to 11 coulomb per kilogram. Okay, this is the specific charge. Next, although both the beta particles and cathode rays are fast moving electrons, but they differ in their origin. We can see that the beta particles are originating from the nucleus of an atom. Beta particles from nucleus. What about cathode rays? Cathode rays are originating from the orbital electrons itself. Okay, so we got 3 points three properties of beta particles. Next, the speed of beta particle is of the order of 10 raised to 8 meter per second, but it will be less than the speed of light, which is 3 into 10 raised to 8 meter per second. Next, beta particle ionize the gas through which they pass. We have said ionizing power is the highest for alpha particles, which means the ionizing power of beta particles will be in between that of alpha and that of gamma. Okay, it will be less than the ionizing power of alpha particles and greater than the ionizing power of gamma radiations. Okay, that is, when you compare, you can say that the ionizing power of beta particles will be 1 by 100 times that of alpha particles, and the ionizing power of beta particles will be 100 times that of gamma particles. Okay, next, the penetrating power of beta particles is more than that of alpha particles but less than that of gamma radiation. So here you can remember betas, everything is in between alpha and gamma. Okay, now here you can see that the beta rays can pass through a paper. Okay, that is about 5 meter in air they can travel, they can pass through a paper, a thin cardboard or a thick paper it can pass. Okay, when you take thin aluminium, if you are taking thin aluminium sheet, okay, sometimes these beta particles can pass through thin aluminium sheet. So if you are taking of thickness 5 millimeter, if you are taking an aluminium sheet of 5 millimeter, it can stop the beta particle. It won't allow the beta particles to pass through it. Okay, so this is a penetrating power. So penetrating power of beta particles also you can say that it will be 100 times that of alpha particles and 1 by 100 times that of gamma particles. Okay, next, beta particles are negatively charged, so they get deflected by the electric and magnetic field. This also we have discussed. Okay, we know that the deviation produced by beta particles is greater than that of alpha particles, and the gamma particles produce no deviations. So beta, you can see it has bent more. Okay, so beta particles, they are negatively charged and it will be bending towards the positive plate in case of electric field, and magnetic field means it is towards the right. Okay, like alpha particles, beta particles also affect photographic plate, images can be formed. Next, beta particle cause fluorescence on striking of fluorescent material. We understood what is fluorescence. Next, beta particle produce X-rays when they are stored by the metals like tungsten, which is of high atomic number and high melting point. Metals, when you take, we can use the beta particles to produce X-rays. Next, beta particles cause more biological damage than alpha particle. We have already discussed alpha particle cause biological damage, but we have said that it is difficult for alpha particle to pass through the skin. But when you take the case of beta particles, they can easily penetrate to the skin. Okay, therefore they can cause more biological damage. So these are the points, these are the properties of beta particles. Again, we have discussed 11 important properties of beta particles. Now the properties of gamma particles. Gamma radiations are the electromagnetic wave like X-rays and light, but they differ from X-rays and light in wavelength. So the wavelength of gamma rays is of the order of 10 raised to minus 4 nanometer or 10 raised to minus 13 meters. Okay, we know that for X-rays, what is the wavelength range? We have studied this. For X-rays, the wavelength range is 10 raised to minus 2 nanometer to 10 nanometer. And for light, visible spectrum we have studied. For visible light, it is 400 nanometer, where violet starts to 800 nanometer. Red light ends. Okay, so when you compare the wavelength, they are similar. Gamma radiations are similar to X-rays and light, but when you compare the wavelength, you can see there is a huge difference, right? Okay, next, the second point, the speed of gamma radiation is same as that of light. What is the speed of light? Speed of light in air or vacuum is 3 into 10 raised to 8 meter per second. Okay, so we have said, when you compare the speed of alpha, beta and gamma, the speed of the gamma rays is the highest, which is same as the speed of light, which is 3 into 10 raised to 8 meter per second. Next, the ionizing power of gamma radiation is very low. We have said ionizing power is the highest for alpha, then comes beta and then gamma, which means the ionizing power of the gamma radiation is 1 by 10,000 times that of alpha and 1 by 100 times that of beta. So ionizing power of alpha, highest, ionizing power of beta comes in the middle, and then ionizing power of gamma radiations. Okay. Next, the penetrating power of gamma radiation is high. Just the opposite. Okay. Penetration power is the lowest for alpha, then comes beta, and then you have the gamma radiation. These gamma radiations, they can pass through 500 meters in air. Okay. You can see that alpha rays get stopped by a thick paper. Beta rays can be stopped by a thick aluminium sheet. Now, to stop the gamma rays, you need to use a lead. It can easily pass through the paper and aluminium. Also, if you use iron, gamma rays may pass through the iron. Okay, so this is the difference. So, to stop the gamma rays, you need the thick lead. Clear? So, if you take a 30 centimeter, somewhat 30 centimeter thick iron, still through this iron, the gamma rays can pass. Got it? Next, like X-rays and light, we have said that gamma rays or gamma radiations are similar to X-rays and light. Gamma radiations are also not deflected by the electric and magnetic field. We said gamma radiations are electromagnetic in nature. We know that X-rays are electromagnetic. X-rays and the light, visible light, belongs to the electromagnetic spectrum. Gamma rays are also a part of electromagnetic spectrum. We have studied in the chapter spectrum in detail about these radiations. Okay, so these gamma radiations, since being electromagnetic, they cannot be deflected using the electric and magnetic field. So when we discuss, we have seen that the gamma radiation will be moving undeviated. Next, gamma radiation affect photographic plate. Alpha, beta and gamma radiation, all of them affect the photographic plate. Next, gamma radiation cause fluorescence. We know what is fluorescence when they strike a fluorescent material. Gamma radiations are also diffracted by crystals like X-rays. Okay, so X-ray radiations can be diffracted using crystals. Okay, using crystals you can diffract the X-ray. Similarly, when you use crystals, you can also diffract the gamma radiation. Okay. Ninth property, although X-rays and gamma radiations are similar in properties, but their origin is quite different. These gamma radiations, we know that they are originating from the nucleus of an atom. Now, when you take the case of X-rays, we get X-rays due to the transition of electrons in the inner orbits. We know that in an atom, there are different orbits, and by gaining energy or giving out energy, what happens to electrons? Electrons can jump from one orbit to the other orbit. It can go from this orbit to this orbit by gaining energy. Then from this orbit, an electron which is in the third orbit can come to the second orbit by giving out energy. Okay, so during this transition of electrons, what happens? X-rays can be produced, and the gamma radiations comes directly from the nucleus of atom. It is not related to electron. Next, gamma radiations can easily pass through the human body, therefore they cause immense biological damage. So in comparison, alpha doesn't cause much damage, beta cause damage, and immense damage is caused by the gamma radiations. Also, these gamma radiations are very useful in the treatment of cancer. For treatment of cancer, which radiation is used? Alpha, beta or gamma? Gamma radiations are used for the treatment of cancers. Now, we can easily remember the points just making a comparison between the alpha, beta and gamma particle. You have to just remember the different properties. First four properties that we are going to discuss is 1 nature, 2nd speed, 3rd rest mass and the 4th charge. Okay, so nature, what is the nature of alpha particles? They are positively charged. Okay, what about beta particles? Beta particles are negatively charged. What about gamma? Gamma, they are highly energetic electromagnetic radiations. There is no charge. Charge is 0. They are electromagnetic radiations. Okay. Next, when you compare the speeds, speed of alpha particles, it is nearly 10 raised to 7 meter per second. That of beta particles, when you take about 90% of the speed of light. What is the speed of light? Speed of light is 3 into 10 raised to 8 meter per second. 90% means 90 divided by 100. Okay, cancelling 9 into 3, which is 27. 27 by 10, 2.7. 2.7 into 10 raised to 8 meter per second. So, you can see that the speed of the beta particles is in between that of alpha particles and the gamma radiations. Okay, gamma particles, it's very easy. 3 into 10 raised to 8 meter per second is the speed of gamma particles. Next, rest mass, 4 times the mass of proton. We have said, okay, 4 into mass of proton, and we have calculated it 6.68 into 10 raised to minus 27 kilogram is the rest mass of alpha particles. Now what about beta particle? It will be same as that of electron, because it is related to electron and not proton, not related to proton and neutron. Now what about the gamma particles? They do not have mass. Okay, no mass. Next, charge, positively charged. Beta particles are negatively charged. What about the gamma particle? No charge. Okay, so with this 4 important properties considered, we can compare and study all these points. Okay, next we'll take the 4 properties, which are specific charge, wavelength, effect of electric and magnetic field, then ionizing power. So specific charge is nothing but charge divided by mass. Specific charge of alpha particle, if we know the charge of alpha particles and the mass of alpha particle, we know the values, we can divide and calculate the specific charge of alpha particles, and you will be getting the value 4.79 into 10 raised to 7 coulomb per kilogram. How do we get this? Charge we know, which is 3.2 into 10 raised to minus 19 coulomb, and mass is 6.68 into 10 raised to minus 27 kilogram. So when you divide, you will be getting the value 4.79 into 10 raised to 7 coulomb per kilogram. Now the specific charge of beta particles 1.76 into 10 raised to 11 coulomb per kilogram. How do you get this? You will be taking the mass of beta particles and the charge of beta particle, which is same as that of electrons. Next, to find that of gamma particle. Gamma particles have no mass and no charge, so there is no specific charge. Okay. Next, wavelength. Alpha particles and beta particles do not have wavelength, and the wavelength is only for the electromagnetic radiation, which is the gamma particles, which is 10 raised to minus 4 nanometer or 10 raised to minus 13 meter. We have compared it with that of X-rays and visible light. Next, effect of electric and magnetic field. What happens to alpha particles in effect electric and magnetic field? There is deflection, right? Less deflected, but opposite to that of beta particles. Okay, always there is a deflection. Comparing to beta particle, it is less, but will also be in a direction that is opposite to that of beta particle. If beta particle is towards the positive plate, then the alpha particle will be towards the negative plate in case of electric field. When there is a magnetic field, if beta particle is to the right, then the alpha particles will be towards the left. Okay, more deflected than alpha particle, but in a direction opposite to those of alpha particle. Same point. Okay, just you have said. What about gamma particles? There is no deflection. They are unaffected. Whether there is an electric field or magnetic field, gamma radiation will be going in the same direction in which they are moving, because they are also electromagnetic radiations. Next, the ionizing power. Ionizing power of the alpha particle is maximum. Then that of beta particle comes between that of alpha and gamma. It is less than that of alpha particle and greater than that of gamma particles. What about gamma particles? It will be the minimum. Okay, so we have made the comparison 1 by 100 times and 100 times. Okay, so when you take beta particles ionizing power is 100 times that of gamma particles and 1 by 100 times that of alpha particles. Next, 3 more properties. Penetrating power range in air. So the penetrating power is the highest in case of gamma particles and it is lowest for alpha particles. Small, 3 to 8 centimeter in air. Okay, next, beta particles large up to a few meters in air. And what about the gamma particles? Very large, up to a few 100 meters in air. Okay, they can penetrate deep. Next, the stopping substance. Just by using a thin paper or a human skin can stop the alpha particle. What about beta particle? About 1 millimeter thick lead, okay, or 5 millimeter thick aluminium should be used to stop the beta particles. Beta particle easily pass through a thin paper or a human skin. Next, what about gamma? About 30 centimeter thick lead sheet or few meter thick concrete should be used to stop the gamma radiations. Biological damage. Where is it maximum? Maximum biological damage is caused by the gamma particle. Less damage in case of alpha, more damage in beta, and immense damage is caused in case of gamma particles. Okay, that's all for today. In today's class, we have discussed about the atomic structure, the nucleus structure, and also discussed about radioactivity. We have studied about the different radiations, alpha, beta, and gamma, their properties in detail. Hope you all enjoyed the session. I'll be back in the next session. Until then, stay tuned to Learnohub. Learnohub free hai, par best hai. Thank you.